on my best day with a soldering iron,
Yeah.
I am not like 1/10 of what Nick can do. I've had him solder up some things. I come back, I'm like, how do you do this? You know, I mean, like, when I would weld, my brother and my dad would say, oh, you're just like a dauber. You know, my welds were like ugly and metal, and that's the way kind of my soldering. You're just like a daubing, and his stuff, it just flows. So, with that, Nick is going to talk about various things. I did try to ask him to be sure and plug his newest servos. He's got the super lightweight, what is the others? He's got more torque out of them. Very intriguing stuff about how they did that. And then he's going to talk about molding micro props out of flat sheet fiberglass, right?
Would Nick Leichty please come up and do this presentation?
Now for a down-to-earth seminar that we can all participate in. The molding of the propellers. Why do we need to mold our own propellers? At first, I wanted to do counter-rotating props. And there wasn't counter-rotating props available at the time for little planes, little twin-engine planes. I figured, okay, we got to figure out a way to do this. I started doing little balsa hubs and cutting out Kapton plastic blades and gluing it together. And so I used that for a while, but then I come across something on the internet where somebody was molding something across a round tube, and I thought, well, that's a good concept, but what kind of a shape do you need to be able to do that? You know, straight propeller, how you going to get it to? So I figured, okay, offset the blades a little bit. But then they started coming out with all these little quadcopters, all these little tiny propellers, and with a quad, you got right hand and left hand props. So I thought, great, you don't have to worry about props anymore. So I started putting them on the planes, especially like the little plane here. I left it on there. The weight of these plastic propellers is like a gyro in the nose of these little airplanes. And you find that when you make a left turn, oh, it's nice. You don't even have to hit the elevator. It just goes right around. You make a right turn, that thing dies. And it's like, why is it doing this? You know, you got a gyro on the front of your airplane. So the reason for the lightweight props, I eliminated that problem. So that's the whole reason that I went back to the the fiberglass propellers and started molding them. What I want to pass around is some of the material for the 6-inch diameter propeller that I'm running on my little coaxial unit. And I'm not gonna take the time to mold one today. Already got one molded. But you can see the difference in the flexibility, and this is out of the 10,000s material. In the real small planes, I'm using a 5,000s.
Where do people get this material?
You get it from me.
There you go.
It'll be on the website after this. But anyway, of course, the molding of it stiffens it up big time compared to what it is to start with. And of course, that works too with the smaller props. This is the 5,000s prop here. As you can imagine, I don't. So anyway, I'll pass around the material. That's the 10 and the 5 ounces thickness. And a blade made from the 5. And a piece of the 10 with a molded 10. So that's that. How I go about doing this, I draw up the props on the CAD machine and print it out on the sticky back paper. You just use an X-Acto knife, cut out the piece. Once you have the piece, you can put it on your material, which I just sent off. The way I made these though, the one side is perfectly straight and it parallels the other side. So if you have like a paper shear, it's easy just to shear these things up into width. And then the only thing you have to do, you can cut this part out close with a scissors, and then a little battery operated Dremel tool, get into the radius and finish that part off. So it's easy, straight cut, 2 straight cuts, clean up the ends, and you get the shape. So that's the shape. And the nice thing about this is you can make a left-hand prop, or you can make a right-hand prop. However you place it inside the tube for molding. So to do that, show you what I do here. Take a little piece of masking tape. I put it across the tip, and I figure the tip isn't going to get as much molding as the rest of it. So then you take your mandrel piece, you scribe a center line down it. And the other thing, but before you get your piece out of your paper, you want to make sure you put your hole in the center. So once it's molded, you can't find that center. So make sure you just take a little X-Acto knife, twist a hole or a little drill bit, get that center hole so you got it after you're done. And then I like to, on your mark here, I like to put the temperature I use, the diameter of the prop, in your inside mandrel diameter. And the outside mandrel diameter is not the next size. It's 2 sizes up from your brass tubing selection, of course, so you can get your prop inside. Now on the other ones, the smaller props, I actually take the brass tubing and machine it off a little bit. And then you do use the next size up to encapsulate it. So I've got my center mark. I got a mark on my masking tape here. Take the prop, put it on there, get it centered up. Take the ends down. Just like that. And you're all set to go. You take your mandrel piece, in there with a deburring tool, flare it out a little bit so you're not cutting up your prop. As you put it in, fold your edges down and just work that right up over the fiberglass material. All the way to there. Then you got your prop inside your brass tubing. The next thing you need to do, depending on the thickness of the material, I cut out these little wedge pieces. Okay? So you still got your mark on your masking tape, so you know where the prop's at. It's in this area of the housing. So you flip that over upside down, press down, and jam these blades up inside there. That helps pull the top tube down tight onto your propeller piece. So now you're set. You're set to go with it. Originally I started using the heat gun, which works great. You got your line at the front so you know where your propeller is. And heat it at the back side. That way you're getting an even heating across the thing. Otherwise you're going to get bubbles and blisters if you're trying to do it on the front. And this was working great for the smaller propellers. Okay, you can just work it back and forth, and hold on to it. Once it gets to a point where you can't hold it anymore, you're ready. You dip it in some cold water, cool it, set it, pull out the parts, take it apart, and you got your propeller. But then I started finding out, okay, you have this little toaster oven. This is going to be so much better. Or controlled. Let's see. 300 to 320 degrees. Toaster oven. Your tabs keep it from rolling around. Stays up vertical. So I don't use it on broiler. Use it on the regular lower elements, and keep the prop up on top, and it comes out pretty good. You play with the heat, the duration. Usually I'll set it in there, not even preheated. Set it for 20 minutes, and that seems to work out best for me. 20 minutes, non-preheated at 300 to 320 degrees. If you get it too hot, you start getting bubbles in it. It'll start expanding gases inside the material maybe, and it starts to bubble.
Nick,
But,
when you put the template in there, are you angling it?
I just put it in the middle of the rack and go at that with it. But anyhow, you can pass that around and see what that looks like then.
And I think I don't know if he was asking. There are some people who do props, particularly when they're doing a single blade. One side where they kind of rotate
Oh,
it
as far as
slightly.
not keeping it aligned.
So
You
do
just
a
gotta
pitch
play with it a
change.
little bit. I try to keep to where the leading edge of the blade is just across the center line, so it's getting just a little bit of a hook into it.
Right, and then the trailing edge has more of the curve.
Right. But yeah, you get all different size. You know, once you start trying different propeller sizes and diameters, you come up with your different brass tubing sizes for each, and just make a record of it, and that's what works best for you then. Any other questions about the propellers or how it's done?
Do you use any release agent, or does
No.
it just come out?
No, just put it in as it is. Sometimes I'll sand both sides of the blade. You know, you just work. You got to be careful because you get too much pressure on it, you're going to buckle that blade up. So you got to hold it, work a little piece at a time, sand it. That gives the shine off of it. And I don't know. Sometimes I figure, well, does that help let the gases out where you don't get the blistering in it? I haven't found it that's necessarily the case with it. Yes, Martin.
Do you have any information on weights and how it compares with carbon fiber propellers?
No, I don't.
I thought the weights were on your
I really
website
don't.
for the ones you sell.
What's that?
I think your website lists these props, and I think you've got the weight for at least some of the standard props that you sell on your website. I think you've got weights there.
Yes, I do. I do, but I don't have the weight for.
No, but the point is that
fiberglass.
somebody could go on your website, get it, and they can weigh a plastic equivalent prop that they have, and they can get the weight comparison.
Yeah, because I make all the different sizes. You know, people tell me I'd like this size or that size. So, and as far as the pitch, you know, it's kind of a guess.
Do you
Just
have to
with the pitch.
balance them afterwards, or
Sometimes,
materials
yeah,
pretty
yeah.
consistent?
I used to drill out the center and use a piece of solid wire insulation, glue it in for like a hub, to where you could just press it over your shaft then. But I found, even on my coaxial 3D plane, I just glued it to the shaft, just to test it, and they never came
Never
off.
touched it.
It never came off. They never slipped. I slammed the thing in the ground running. It didn't break. It didn't come off. So forget the hubs. Just glue it on the little shaft and you're good.
Have you ever tried doing it with circuit board material, like the 132nd or the real 164th?
Well, that's what this is.
That's so it's the same.
It's the fiberglass circuit material, circuit board material.
Yeah, but it's Garolite, same stuff. You know, we buy it at MasterCard. They sell, and that's what I use. Garolite. I made some of the next props.
Right.
Same,
And it.
Now,
Joe and I are
we-
using it. We're making control horns, little wheels.
I
It's,
make everything
it's
out of that
wonderful
stuff.
stuff.
I use the scraps for control horns, and it's like, well, I guess I could do.
Right, now you're saying Garolite. Now the Garolite on the McMaster car, I think, is a paper wrap
Yeah,
material.
that's the flame retardant stuff.
You know,
No, it's,
this
I'll
is
show you
like a
now.
G10. They're calling this
It's,
more like a
what's called
G10
G10,
circuit board.
but they still call it Garolite.
Oh, it's
G10
all in the
Gar-
Garolite family.
Is
Right?
it? Maybe it must be in the family.
Yeah.
Yeah.
Yeah,
It is-
you're right. It's G10.
It's
yeah.
G10.
And you get a collection of thicknesses and.
Right.
Right.
But it must be very much the same material.
Yeah.
Same.
Yeah.
Can you talk about pitch, not determination, but you know, how do you figure out what kind of pitch you want in terms of the diameter? You know, I mean,
Well,
to that?
yeah, that,
Because I see a lot of pitch.
yeah, but that's the one I'm using right there as it comes off the,
It
the
works
mold.
perfectly.
Yeah,
Well, the
works
size
fine.
of the tube, right? You're using the larger tube for the larger props and the smaller tube. I mean, what the diameter
Right,
your
right.
tube is. But
If it doesn't seem like there's enough pitch to do the job, if you've got a motor that's running quite a bit faster, you want a little bit less pitch, you know, the problem there, just use the bigger diameter tubes and, you know, but you gotta play with it a little bit and see what's worked best for you. Like the email whoever sends me, you know, information where they want a prop to, well, what are you using it on? You got a gear reduction or now the little tiny props that I make for the E20 motors, that's a direct drive, super high speed, 2 3/4 inch diameter propeller. I use the 15 thousandths material for those because it's so stiff. It's got to be so stiff to handle that high RPM. The other thing that I made a change on, I used to have like a curved scimitar tip on the propellers, and that always worked fine for the little propellers that I was making out of the Kapton type material. But as soon as I started going with the bigger propellers, I found that being molded and twisted, the tip being curved to the backside had a little twist of increased pitch at the tip. Okay, so I'm looking at that, and because I'm getting cavitation issues, so I had to go to a thicker material. And I'm like, oh, I sure wish I could use that thinner material. And I'm looking at that tip, just slightly kicked up a little bit, and I'm thinking that's probably the reason I'm having problems. So I squared off the tip to the radius of the diameter of the propeller, just radius the ends a little bit, eliminated the cavitation problem, and I'm able to use a much thinner material without getting to flutter as it runs. Any other thoughts on it?
Gordon, how does Ruslan do? He just adds like a light fiberglass over the top of the foam.
So Ruslan makes 2 kinds of props right now, and I think I passed a couple of them around.
Right.
So he's got, in my estimation, that you can currently buy
Yeah.
the lightest, small, good, all carbon fiber props. And it's funny, I put one on my little blue Citabria plane, and it's 4-inch. And I also have a 4-inch micro invent. So I weighed them. They're almost identical.
They're almost the same.
His has, it looks like a miniature GWS props. There's more cord between the leading and trailing edge. And so before I did on the plane, I did at least static tests. To my surprise, I thought I was going to get higher amp draw and more thrust out of his wider blade. The thrust was almost exactly the same, but his had a tiny bit lower amp draw than the micro invent. So the micro invent, but you can't buy micro invents anymore.
No.
So he's got those. Then he's got these foam props, which he's really doing larger ones, and he seems to be pretty much below about 6 or 7 inches. He seems to have shifted over to the carbon fiber. On my one little red Maltese cross plane, it's got a little foam prop that he just threw in. And so then when I tried to order some more, he goes, "Ah, that was just like a prop. I cut it down. I've never made it again. I can't get him to make them again." So he doesn't have any little foam ones. So his foam props, 6 or 7 inch or larger, they're some kind of molded. We were like looking and talking about these the other day, but I don't know if it's pressure molded, heat molded, whatever. And then Graham, I think, kind of got some information from him. They're skinned with a very, very lightweight fiberglass cloth that's not tissue, and then reinforced with some carbon fiber tissue.
The reason I'm asking is I've actually molded Nick's props out of Durabatics foam. I printed them, molded them in the same form, and they come out, but they're not very efficient. A lot of drag with the foam. So if you could cover those with some light fiberglass cloth, they would probably be lighter than those and probably as efficient.
What's nice about Ruslan's foam props is they're like a molded GWS or other prop where it actually has an airfoil. And when you get the pure carbon fiber molded, they're basically single thickness and they're under camber. And what the one little foam one that I have that's that size, it draws less amps. That thing cuts through the air. It's a work of art.
I'm just thinking away like Nick's got a simple design. It's pretty easy to make. If you could take one of those, make it a foam, and put a light coat of that fiber. I don't know how he's doing the fiberglass, but that would probably weigh, you know, a lot less.
You might be able to like make a because what you're doing is like you're softening the epoxy
Yeah.
and resetting it. So you could make a sheet of laminated Durabatics or something,
That's
and
an idea.
then do the same
And then
thing.
do the same thing after you, after you laminate.
To soften the epoxy a little bit.
That's it.
I have
Okay.
most of the source for that. I have the fiberglass, and no, I mold them too. And I figured out next, like I said, I can do from like Ruslin's. Probably 70–80% is nice and finished now. But to do that, you need to have an acupuncture.
Right.
But it's not hard.
It's doable. All right, cool. Sorry.
So I can
Okay, I just like the thinness of these propellers, and you know, you can sharpen the edges of them a little bit, and it'll cut through the air really nice. But anyway, it's a cheap propeller, simple to make, and you can make them right, left hand, you know, and you don't get the gyroscopic effect on the nose of the little airplanes. Let me go ahead and pass this around. This is just shows some of the things that we've come up with. And when I say we, it's me and Sergio Zegras. It's a 50-50 operation. So when you say Nick Servos, it's a LZ servo.
That's right.
He's 50% in this as far as how this all operates here. Also send out one of the little actuators. This is what I call my in-house actuator, where it has an actual output arm for pushrod use, but it is a magnetic actuator. You can play around with it with the magnet that I'll send around, or you can actually turn it and it almost acts like a compass. The little tiny magnet then that thing is so strong, you know, that it acts like a compass if you turn it. But these are some of the magnets that I use in the bigger actuators. But what I do is take a stainless steel tube for my shaft on the in-house, the actuators, and actually mash it flat right where the magnets are going to go. And it just collapses and kind of breaks in the middle. So you got the smooth part or rounded portion above and rounded portion below, but you got this flat area in the middle of it. So your magnets stay nice and straight, nice and flat, not on a rounded surface anymore. So you just adjust them to where they're not collapsing one side or the other. A little CA in there. Get that up into the housing first, and then what I'll do is get it turned one way and put another magnet on that, and turn it around and put the next sign on here. Turn it back, put the next size down, and the next size down. So I'm creating this spherical magnet inside this housing. It's not just a flat tube magnets. There's multiple magnets inside these housings. So it helps really generate the magnetic ability of the actuator. So I'm getting a tremendous amount of thrust out of these little magnetic actuators when they're in the housing like that. Let's see, the next thing what I wanted to send out is this little plane. This has got our latest little servo, the 0.4 gram servo in it. This was our test bed. So maybe as this goes around, first person can see the plane and hold it. Next person can work the transmitter. You can both watch how the controls work, how the servos work. We're trying to get as much power out of these little tiny servos as possible, but with the minimal amount of gearing involved, it's kind of a trade-off. You get too much power and they become sensitive and they start to chatter. So we started using some resistors to kind of back off on the motor a little bit, but we figured, well, that's kind of killing our purpose here. So we just backed off on the sensitivity of things to where we were able to get them to be nice and smooth now. So our latest addition, and this is the 0.4 gram servo. I've also got that on that little plaque, the 0.5 gram servo, and that one we're getting like 30 grams of thrust off the output arm. Originally we were only getting 10. Now the little tiny servo we're getting 10. So we figured that's a pretty good amount of power off these little tiny servos. for any little tiny planes like this. And well, let's see. Any questions about the servos? Or
To the best of my knowledge, there are no other commercially available proportional servos, we're not talking actuators, on par with these weights. And if you saw, you know, like Joe's or my, you know, somewhat bigger, you know, 18-inch carbon fiber plane, I'm flying that with 3 of Nick's newer, you know, higher output 0.5
Right.
gram servos. And I spot your servos on pictures of planes in Russia and Finland, and pretty much if people want a plane it's appropriate for those, you're not getting that kind of weight by stripping down a rotary servo from Hong Kong. You're just not.
There's no way.
Do you actually have a full pit algorithm running in them, or do you have to kind of do approximations to get it to fit in, you know, the little 6-pin pick or whatever microcontroller you're using?
that you're gonna have to talk to my programmer, because that is over my head. I'm the mechanic guy. I'm into the
Soldering,
mechanics.
does the,
It's
program.
full-time algorithms over there with the overshoot protection and jittering, de-jittering and everything else. It's everything in there.
Yeah.
It's good he lives not more than 10 miles away now.
Nice.
Because we're under the servo development. We're together a lot.
I need somebody to do my soldering.
What frame rate can it take?
Children,
What is the highest frame rate?
4 milliseconds. Yeah.
So 250 hertz?
Yes,
Okay.
that's for the drones and stuff. Because you can't get away with 15 or 20 milliseconds with drones.
This is
As a
one
matter
of
of
the
fact,
little.
we found out that the Gasparin speed controllers for the brushless motor didn't work at that rate. We were going crazy because we were trying to make the smallest and lightest drone, and we figured out if we use Gasparin's ESCs and brushless motors, the small ones, will be great. But it didn't work, so we contacted their engineering department. Sure enough, they don't work at that rate. So,
You want
you
to
have
mention the
use
fact
brushed motors.
the price, amazingly, on these, as they've gotten more torque and lighter, has actually come down. I remember you being here at NEAT and you showed one of the servos, the very first version of the LZ, and you didn't have it even on the website yet. And I'm doing this from memory. I think I paid $125 a servo for it, and I believe you're down in the mid 60s now.
Yeah.
So think about this. You know, they've come down in price. This amazing servo's gotten stronger, lighter, and the price has actually come down.
Yeah, we were driving the original ones right off the pick chip, multiplying some of the output pins together, but it really didn't multiply as much as we were hoping. So the newer servos, and of course the lighter servo, uses a much smaller pick, and we're going through an amplifier now. And the amplifier and the little pick is about 1/2 the weight of that one pick chip originally. So we get a lot more power, and it's a much lighter weight.
There are some really, those 3x3 DFN motor driver packages now that just make that part so much easier.
Yeah, right.
Double H bridges.
This is one of the little circuit boards for one of some of the little receivers that I make.
Do you
The
do reflow soldering?
nope, I've never got into that. I use
You're
the,
hand soldering those DFN packages?
yeah,
Point to point.
yeah,
I've done it.
using the
It's not
solder
easy.
paste.
Yeah.
When under the microscope, you can count out, 20 little balls of
balls.
solder on one side, 20 little balls
So
on
what
the
you're telling me is I need the microscope.
stereo microscope.
Yeah.
Yeah, I couldn't survive without that. That's for sure. Let's see. I could pass this around. This was something that I had come up with for the hinges. With the little actuators, it was nice to have some feedback on these things. So before, using like an in-hinge type actuator, previously called it like the bird actuator. You've got the coil, in the fin, and you've got the magnet attached to the rudder. And that magnet portion is inside the housing of the actuator. Should show it like this. So as the polarity changes on the magnetic coil, it deflects the rudder. Okay, but there was no way to stabilize this unless you put another magnet somewhere, or I started using little rubber band hinges. Use the rubber out of a golf ball. Super tough. If you ever pull the golf ball apart, you take that little tiny strand of rubber and you just can't hardly break it. It's so tough. Some of them I've had the same hinges on the planes for 5-10 years, still working fine. But then now the other thing too, of course, with the hinges, once I started making the in-hinge or the housing type hinge, you can put two of those opposite one another and they feed back to give you your feedback by pulling on one another, but the one doesn't interfere with the other. So that works really great. But then too, started using that type of actuator in a lot of my planes, so I thought, well, I don't need to use a rubber band hinge, I want something much freer. So dental floss. It's super tough, and it lasts almost forever. But a little bit of CA on one side or the other, use the foam-free, foam type CA, and you can get that to stick on real good. So that's the propellers and servos. Next thing I'd like to talk about briefly would be the latest that we've got going now on the hip hop. Hip hop. Look at that. He looks right up. Mr. Martin Newell come up with the hip hop radio system, like he mentioned, he's using in all his microplanes. And I'm doing the building of the receivers, both the Rabbit and the Cricket circuit board type receiver. And the latest thing that Martin's come up with now that we're implementing in both receivers is it's configurable now. So an actuator receiver is not really an actuator receiver unless you want it to be, because by moving the sticks you can reprogram it to get servo outputs on the outputs of the receiver now. So if you want, you can have a plane with actuators for the rudder and elevator and configure the aileron pins instead of actuator, you can configure that to servo. So vice versa, however you want to do it. So he's made that available now. So there's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 different options, or 10 different options that you can have with that receiver now. And the 11th one is back to factory reset. So that's good to have with that. So you almost have two receivers in one now. And then on the transmitters, the Hip Hop 2 version transmitter. And another thing too, if anyone happens to have a Hip Hop 1 transmitter, you can send it back in and we can reprogram that for a Hip Hop 2 type transmitter. Something too that these transmitters have, if you have the Hip Hop 2 type transmitter, can also by configuration can be adjusted to a Hip Hop 1. And Martin, am I right in this, that all the other features are still available even if you switch it to Hip Hop 1? Okay, and those features are half rates. You can go to a half rate. The third item, well, let me see. The first item, the first position, you can select the model you want. Up to 20 models you can set up. The next option would be you can select either Hip Hop 1 or Hip Hop 2. Third option would be half rates or full rate, servo control. Number 4 would be Expo. I think there's 3 positions on the Expo, 25, 50, and 75%. Something like that on the Expo control, which I found very helpful when I started flying some of the little planes with servos compared to actuators. Actuators have more feet, airflow, it pushes it back, it's not as absolute when you deflect the control. So a little Expo, when you're flying little planes with servos, can really be a benefit. Mixer selection, you can V-tail, right? And I think there's a helicopter mix also in with that. The sixth position option would be to calibrate the sticks of your transmitter. If you were using a module, one of the models, then it would calibrate to your transmitter. Let's see, servo reversing is also available on it then. Servo slow just makes the servo move much slower for your stick operation. For retractable gear and flaps. Okay, very good. And then the last one is an automatic range check. So you can put the transmitter into that particular mode, set the transmitter down, and walk away with the plane. And watch the control surface slowly move back and forth, so you know how far you can go and still have control of your plane then. So that's it with the hip hop. Any other questions about hip hop radio?
Nick, how many channels are you gonna have available? You gonna I know is your hip hop receivers? How many?
Well, the Rabbit is basically four for actuator.
Right.
But of course, if you can reconfigure those, you can get what, 8 now? I don't know, maybe 7. Because we're using one for the brush motor. Yeah, you've got a brush motor output.
Right.
That's always there with the MOSFET on the receiver.
Right.
And then there's another pin that you can go into your brushless speed controller for brushless mode.
Nice.
So that's the way that works. Okay, good. I'm done.